Good evening, everyone. My name is Flavia Bianchi. I am from Dogpatch Labs, supporter of the Dublin Data Science Meetup. Today we have Dave Curran to talk about this topic. I'm gonna leave the introducing for Mick. So I just wanna help you guys with the crowdcast. So if you wanna ask any question, there's an ask a question button. If you wanna engage, there are a few polls happening here on the side. And if you want to talk to the speaker or to Mikuni, who is also going to be part of this talk at some point, you can use the chat box on your right. I'm going to leave my email here in the chat box in case someone is planning a meetup and is looking for some support. And you can drop me a line and maybe we can help you guys out. Hope you enjoy. I'm going to pass it on to Mick so he can introduce David, and you guys are going to be good to go. So
hi all. So thanks everyone for coming to Dublin Data Science, the July 2020 coronavirus edition. Tonight I'm delighted to be introducing Dave Curran. He's a long-time attendee and speaker at basically the various meetups that we've organised around Dublin in the last few years. So he very generously met me on a bus one morning when I was barely awake, and he said, "If you want me to give you a talk, I'll happily do so." And I said, "You're probably going to regret that, Dave, because I remember. I have an elephant memory for those kind of things, and especially in the modern day kind of COVID environment when I can't mug people at the bar after talks for future talks. It's his generosity is very much appreciated." So tonight he had a bunch of different talks and to offer, and this one by far was kind of the most intriguing one, although they all sounded great, but this one is just something I have no idea what's coming next. Usually I have some idea about the content, but tonight I really haven't a clue, so I'm really looking forward to it. He's talking about building a Q&A system in Chinese, which I have no idea how you even begin to do that, since it's a completely different language. I'm sure that's one of the topics he'll be talking about. I absolutely agree, Dave. I think Mihai will be a great speaker for the next one. Sorry, I'm just looking in the chat here. Like I said, because of the format, we adapt to the technology. So rather than have me online or whatever and doing the interruptions, I'm going to be monitoring the chat. I think Dave has a second screen as well. So if you have any questions or comments or whatever, please put them in the chat. You'll see me, typing quite a bit. And yeah, so tonight we're introducing Dave Curran. He works at OpenJaw Technologies. He can fill you in on that. And yeah, he's going to talk about building a Q&A system in Chinese. And then after that, we're going to come back on at the end, and he and I will have a bit of a Q&A at the end. But in the meantime, please put everything into the chat, and I'll hand over to Dave.
Oh, that's me. Mick, I'm having slight trouble with the other chat. Can you see if you can let me into it? Just it's kind of easier if you can see what people are saying during your talk. So, and if you do have any questions or you have any comments, please do say it during the talk, because it's the perfect time to deal with it. So what I'm going to talk about today is sort of the truth behind machine learning. So it's always classed as this sort of fancy dancy amazing new thing, but in actual projects it's a lot more similar to any other software project than you imagine, and I want to tell you what actually goes on and why, just to give you a real look at things. So in this case, what I'm going to talk about is question classification. So there's 3.5 million travel agents in China, which is a lot of people. So sort of most of Ireland is a travel agent, if you think of it that way. And they get questions, I want to book a ticket from Beijing to Shanghai on this date, or I tried to cancel the ticket and I failed, these sorts of things. And they go to the person they bought the ticket off, which in China is called TravelSky, it's called a GDS. And they say, well, can you fix this problem for me? So they have questions, and they are of a certain category of things like cancel a ticket or those sorts of, if you imagine, they tend to be verbs that operate on particular nouns, particular topics. And our challenge is, when one of these questions comes in, can we figure out what the intention is, what the person wants to do? If you're not used to NLP at all, if you just think of it as spam, a spam comes in and NLP has to decide whether it's a real email or a spam email, which of these two kinds it is. That's an NLP problem. You know, you have to think about, do I look at the words, these sorts of problems. So I'm just going to escape here because I'd like to see if anyone's talking, because I can't get into the other side. Everyone's saying hello. Okay, go ahead.
Yeah, what I'll do, Dave, is I can unmute myself. So if anything kind of particularly relevant drops in, I'll just interrupt you if you don't mind.
No worries. It's funny you won't let me in.
Yeah.
Oh,
technology.
It could be some sort of firewall or something. It could be on my side. Sorry about that. So
it happens.
Anyway, okay.
I'll just unmute myself. You'll probably see me on mute, and I'll jump in if I have to.
Great stuff. So this is a supervised machine learning problem where we have examples of questions where people ask and labels on them. And we want to see when a new question comes in, oh wait, what's the most similar to what we've seen before? Which of the groups should it land in? So there's unsupervised stuff in NLP where things like we have newspaper stories. We're trying to figure out what classes of newspaper stories there are and stuff. But this is supervised. Training data is the big task, and labeling that data is kind of a bigger deal really than the actual classification engine. But labeling and everything is a different talk. Tonight we're just going to talk about the classification engine. When you get your data, how do you turn it into something useful? There are big companies that do this. IBM Watson, Google, Amazon, they all at this point have classification engines, even some of the guys in China like Baidu. But we were told we had to make a replacement for those, which is what made it fun. So data we actually had 3 data sets of like 5 to 10,000 labels. So one of the companies we were working with had 20 million monthly users. Like, they're just huge, the apps you deal with in China, just a massive amount of data. In Europe, I've built chatbots for Mercedes and Caixa and Credit Mutuel and like all the sort of European, a lot of the big sort of European companies, but you're struggling to get 2,000 example questions to label there. Over the course of an entire project, you eventually gather together 2,000 with user testing and everything else. In China, the first day you go in, the second day you go in, you tell them what you want, and they come back the next day with 5,000 questions, and you start labeling them. It's just, they have vast amounts of data. This particularly makes a big deal in speech. Their speech recognition is much better, and part of that is because they just have much better data. So just to remind you, we're talking about labeled data here. You've got a question or an utterance and a label attached to it, and that's called your ground truth. And we assume that you've got all that labeled. If anyone was at PyCon last year, I gave a talk on how you label data. But this is, once you have that labeled data, how you make an engine that when a new question comes in, it's going to get to the right label. Okay, so first question is, why the hell were we asked to make a AI engine? So the big companies, the Watsons and the IBMs and the Googles, won't set up in China because they're worried about having to share their code, I think. Medium-sized companies like OpenJaw want to have sort of more control over things. They'd like to be able to say, oh, look, we have our own AI engine and stuff. There's sort of marketing reasons you'd like to say that, and also practical reasons as well. Anything that has to go through the firewall of China, you're going to be slightly worried about. And then there's just the physical physics issue of sending something from one side of China to Tokyo and back again will just take time. So you'd rather cut that time down, even if there was no firewall problems or whatever. Another thing which, again, people don't mention is a lot of these big companies have a data center that's sort of sitting around and currently not doing anything. And they'd like to say, oh, look, we've got an AI engine in our data center. It's something that kind of makes them look a bit better. So they're usually kind of happy if you have something of an NLP that both helps them, but also, you know, the guys who run the data center might be a bit more willing to help you because it's eventually hopefully going to make him look good. In Europe and America, the sort of Watson engine and the Dialogflow and the AWS engine are really cheap. Cost isn't really a reason to not use them. In China, the engines are really expensive, and I never forget why. But building your own AI engine, at least around here, won't save you that much money. They're not in that many languages, which maybe we'll get into a bit. But part of the reason why you'd want to be able to build your own AI engine is if these techniques are really useful and can really make things more efficient, and that only works in the top 10 most popular languages in the world. That means some other languages could, end up being left behind, which really shouldn't happen because of AI. It should help everyone, if you know what I mean. That's probably a different sort of spiel. Okay, so in ML, sorry, go on.
Yeah, one thing I've heard, Dave, is that people saying in like for what's the word? It's polymorphic language. No, there's polymorphic languages where the words change. I know Georgia, because we had a Georgian guy, as he was actually one of the original organizers, and he said a lot of the standard NLP techniques just don't work for those kinds of languages, because the standard stemming and all them completely change the context. So you have to treat them in a completely different way.
There are languages like Russian and stuff where they're just layering stuff on top of things in the words. And actually, the techniques I'm talking about now, some of them will work, but they won't all work, and you won't get as good a quality. But it's some of the Slavic languages are like that. There are probably other languages as well.
Polymorphic. That's it.
Yeah,
polymorphic languages, I think, was the term, or something. But it's basically the same word, but it changes completely, and it changes the context.
I'd have to go into details on one language, but in general, an awful lot of the sort of I looked at Tagalog recently, the Filipino language, and it was actually fine. But anyway, most languages okay, but occasionally you do get ones with very, very tricky things. And also, any language will have something unusual in it. That means it won't work. You'll have to learn something in every language. But here's a sort of a generic series of steps that will work pretty well for most languages. Is kind of what I'm trying to show today.
Right.
So in a pipeline for NLP, you want to read in the data, obviously. You want to kind of figure out the words. The words are sort of the units of information in most languages. So you want to sort of separate out the words and see where the words are. You want to turn it into something a computer can understand. Then there's a few manipulations you kind of do to sort of increase the amount of information, or which increase the signal to noise ratio. Then you use a classifier. An awful lot of people get kind of obsessed with the classifier, and for reasons, but there's other stuff going on around it that's kind of really important as well. And these steps are fairly similar in like an image processing task. You have to label the data well. You have to be able to find what the actual images you want to classify are. A machine has to read them in some way. Most NLP and even machine learning is kind of like this. The A to Z is pretty similar, even if a lot of the sort of internals of the steps is different. All right. So one thing to remember in machine learning is it's very easy to fool yourself, and it's very easy to go off down in paths and never, spend 2 weeks looking at a tiny bit of this algorithm. What you kind of, I think, end up doing best is if you can say, well, this is our metric, this is why we're measuring it, we're making a change, and our job is to get things improved as much as possible in the time we have. So the sort of pipeline I'm describing tonight is the reason why we're doing a pipeline like I described tonight is if you can quickly get an engine together, hand that over and say, right, we've got an engine together, you need to deploy that on your server farm now. All of a sudden, all the problems you're going to get deploying will come up, and you'll have to fight those. But you're better off fighting them early than having to fight them. You get told, oh, if you give it to us 2 weeks before you launch, that'll be fine, we'll get everything set up, and it's not true. So you're better off giving it to them 2 months before you launch, finding the problems then, and then if you do have time, you can build a better, cleverer engine then, but at least you've gone through those sort of setting up problems. So my point here is, if you get an NLP task, get something up and running fast, get it to the guy who claims he can deploy it, get it deployed, and you'll see if there's a problem in all of that steps, and there always is a problem. And that's actually better than waiting until you have the perfect engine and deploying that, because it'll be too late and nothing will work. Anyway, this is my experience of get something up and running A to Z fast, and then go back and fix things. I find in NLP projects is a much better way to go. So,
I found that to be true in all projects, Dave.
Yeah.
There's always something.
Yeah, quick and dirty, and even if it's just the basic, most simple possible version, or even if it just gives back the same answer all the time, even that I'd rather have deployed, just because you can find that the deployment problems as opposed to NLP problems, you know what I mean? Anyway, so Chinese NLP. I don't speak Chinese. I'm weirdly enough able to read bits of it now, but that's a different issue. But just the basics of Chinese NLP, and obviously someone who knows Chinese NLP and deals with a lot is going to say something different. But the first thing is the words are all stuck together. In almost all European languages, there's spaces, so at least you can say that's a word, that's a word, that's a word. There's always issues trying to separate words. There's a band called Portugal the Man that has loads of different characters in their name, and it's just impossible to segment out. But you know, there's always weird side cases in any NLP. But the first task in Chinese is to find out where the words are. They make really clever jokes and puns by having words together, and based on, you can sort of separate them out as a joke in different ways, and it makes it really clever. But we're not doing that task here. So we tried loads of different word segmenting libraries. The best one we came up with was a one called LTP.ai. It's available on their website. It's really good. This is one part where you do need a native speaker. So if you need to do a word segmenter in Thai or some other language, you will need a native speaker. And why is there will be, say, 10 relatively common words in your domain. So if your domain is aircraft, tickets, or your domain is bank insurance or whatever, or say it's mobile phones, there'll be about 10 words that are fairly common that it'll be segmenting wrong. So iPhone might be common in the telephone domain, but it'll see it as I space phone, and it's always getting that wrong because it's not a common word in everyday speech, or at least in the training data. And then you can come along and with a rule and say, by the way, if you see iPhone, these two characters, stick them together because they're actually one word. And if you do that for the 10 most ones it makes a mistake on, that's usually enough that it gets a pretty good segmentation then. So word segmentation, there's usually libraries around for the languages that need them. LTP.ai is the best one we found for Chinese. And you do need a extra fluent Chinese speaker to read over the text and go, oh no, wait, they're getting this word wrong, this common word in your vocabulary wrong, and then fix it. It's quite a quick thing to fix. So then once you have the words, if you do a count above the word, what you want to do is you want to turn those words into a vector, into like an array. I'll describe how that's done in a minute, but just remember, we need to turn the words into something a computer can understand. Then there's loads of weird different chopping up steps to try and get more signal and less noise out of the language. This happens in image classifying as well. They do weird, crazy stuff I never understand, where they flip it and add this and take away that and everything. But the ones in language I kind of understand. And then there's weird stuff in Chinese and all the languages around spelling mistakes and these sorts of capitalization mistakes and these sorts of things. But that's just language. Okay. So
Dave, I was just going to ask that. Yeah. Sorry, like I said, I'm going to interrupt you because you can't
please do. Yeah.
Yeah. I asked this as a question, but I may as well get you here. How are spelling mistakes possible in Chinese? Because it's pictographic, isn't it?
So no, it's not pictographic. It's Pinyin, the one they use now, as opposed to traditional Chinese, is kind of based on the sounds of words. So the spelling mistakes are a lot more involved in things that sound. So it's not even things that sound the same. Yeah, it is. It's things that sound the same.
Like syllables that sound similar.
So I'm trying to think. The horse, is if something sounds a bit like horse, someone will put in that. And when you read it, it makes perfect sense because, oh, look, it says horse when I read it out loud, but it is a spelling mistake because it's a.
That's not the correct way to spell it.
That's not the correct way to spell it. Even though when you speak it out loud, probably no one would notice you spelled it wrong. So they tend to be the spelling mistakes you get.
Gotcha.
So first thing is separate the chunk of text into different words. This is a good library for doing that. You do need to use metrics to judge quality, as in you go through all the steps I talk about in a minute, and we got say 80% accurate. Try a different word segmenter, and if it's 75% accurate, you go, oh, probably that word segmenter was bad. So you kind of have to build the A to Z and then go back and use that to test your word segmenter, if that makes sense. So you get one that kind of works okay, do the next steps I'm talking about, then get another one and see if it gets a higher or lower score. And then when you're happy you've got one that's pretty good, get the Chinese speaker to read through the segmentation, and she'll usually find, oh look, you're getting this kind of word wrong, the I space phone, those sorts of problems are happening. So eyeballing, you need a Chinese speaker here, or if you're doing this for another language, you need somebody who speaks that language for spotting those kinds of errors. So now we have words, and we want to turn that into something a computer can read. And kind of the easiest way to do that is turn it into an array. And this is a bit weird, so I'll try and make it clear. If you were to think of the 1,000 most popular words in English, right? And you had a 1,000 long array, and you were to take a sentence I said. And did he say aardvark? No. Did he say and? No. All the way up to zebra? And no. But the ones he did say, if he said the word, that's a W, it's a 1. You add ones to the places he said them, and you'd end up with an array 1,000 long that would have, say, 14 or 15 ones in it. That would be the things I did say. So that's all you have to do. That's what string to word vector means, is I take the words, and if he said them, find the bit in the array that covers that word and stick in a 1 for that. And then all you're doing from then on is comparing. Actually, I was going to say what you should all read is this big mad book on papers that hits you NLP, but the truth is most of machine learning is actually based on linear algebra. There's a great cartoon guide to it here. So all this sort of comparing array stuff is just linear algebra. And if you fancy cartoons, that's a good one. The other great cartoon guide to things is the statistics guide. So I'm all for, I'll write them in the panel minute, but I'm all for cartoon guides and things where when you get too tired to read the proper books. So we want to turn
Dave, if the word doesn't appear, what happens?
So if the word Beijing is in the training set, but Dalian hasn't occurred, another Chinese city just haven't occurred, then you won't notice it. It won't be in the array to do the comparison of.
Right.
Now, what you can do is you can make a giant array, or you can have loads of training data. But the problem then is you can tend to overfit. So we happen to have had one question that mentioned the word Dalian, but it was in relation to losing a bag. And then anytime someone else mentions the word Dalian, they kind of assume, oh, it must be about losing a bag. But there's ways around that as well, which I'll go into. Actually, it's a good point. I'll bring that in. So you've got this array, and you can just compare it to other arrays. Something as simple as find me the array that matches in the most number of places can be quite a useful match. Where that's particularly useful is what I'm talking about tonight is landing in the right one of 50 well-known problems we have answers to. But if you get to rarer problems, things like email systems, where can you show me one of the 10,000 emails we've ever received before that's most similar to this one? I'll see how they answered it, and I'm going to answer it the same way. The sort of higher up the food chain customer service sometimes have those sort of tasks where it's tell me the most similar to this 2 or 3 emails we've ever seen, and I'm going to use that to help me figure out the answer. Those sort of direct, show me the 2 or 3 vectors, 2 or 3 arrays that are most similar to this email I'm now seeing. That can be quite useful because a lot of the time, the email is most similar to the one that the customer is complaining now is very similar, and that probably has the answer in it. So for the task we're talking about, the comparing arrays kind of works in a groups of arrays issue, but sometimes just comparing against 1 or 2 or 3 arrays is really useful for finding, have we ever seen this kind of weird problem ever before? But anyway. So I think I go into some of these other TF, IDF stuff in a minute. Let me see. So yeah, this is more details about comparing arrays. Something like cosine distance, you probably did in college, or even possibly do it in Leaving Cert, which is just which are the most similar arrays to this arrays, as opposed to which number have most in common. And then there's all the other algorithms. But if you just think of, we're comparing 2 lists of 1s and 0s, or sometimes 1s and 2s and 0s, that's an awful lot of what machine learning is involved in. Even maybe not quite so much we get into the deep learning, but even there, the basics of it is this. So n-grams are a different issue, where I'm talking about looking at one word at a time, but sometimes seeing 2 or 3 words together gives you a lot more information. So if a sentence has the word credit and the word card in it, it tells you quite a lot. But if you know the credit and card are together, that kind of tells you a lot more information. So there's a thing called n-grams in NLP, which is like, what size of window am I looking at when I'm making my buckets? Okay, so something I didn't mention, but I'll go into here, is there are these common things you do in NLP series. So I'll share the Python code. I might actually have finished 1 or 2 bits of it, but I'll share the Python code tomorrow. But this is done in sort of almost every beginning introduction to NLP. One of them is called TF-IDF. So term frequency is, if a word happens a lot in a document, it's kind of important in that document. So if football is mentioned once in the document, it might be about football. If it's mentioned 10 times in the document, it's very likely to be about football. IDF is how weird this word is being in the document, inverse document frequency, how often I'd expect it to occur. And if a word is rare and it occurs, that kind of tells you more. So that's something about what mixed question was there about if a word isn't in your training set, but you now see it. If it's a really weird word, maybe it's really important because it's not a common word and you can boost up its signal strength. These don't actually work in chatbots in my experience. Again, you got to test everything and try TF, IDF, see if it gets you a higher accuracy score in your blind set and your K-fold test. But it doesn't tend to work, and there's two reasons for that. One is the sorts of questions people ask chatbots, sort of 15, 14 words long in English. You don't tend to repeat that much. I have a problem with my credit card. It's a problem with my credit card. It just, so TF doesn't tend to have that much because almost always words occur once. In longer documents like emails and stuff, yeah, TF, IDF is almost always used. And IDF doesn't have that much, kind of for mixed reason that the really rare words, if you do see them and you boost them up, that tends to overfit things in my experience. But again, try and see if it works, but it's one I've seen people use automatically because they think you always use TF, IDF, and NLP, and actually in chatbot processing, it doesn't seem to help as far as I've seen. Stop words are another thing where they sort of glue words in sentences, and they're really useful for parsing in the sense of what does the sentence mean. But just for bag of words, loads of sentences of there, low sentences of telling the system that it has an and there probably doesn't give it that much information. So a lot of the time in English, you're better off removing them. I'm trying to think of the other language I've used. French, yeah, there's a lot of stop words. I think you're better off removing them. And Spanish usually are as well. Yep. But in Chinese, it doesn't help, in my experience. So try stop word removal in any language you're trying to build an engine for, but try it in the sense of see if it works. Don't just assume it's going to work because it works in English.
Okay. What about German, Dave? Because I know German is a bit weird with the the way they change the words and they have the verbs at the end.
So that's stemming, which is a slightly different thing. I'll go into that later. But as far as I know, I'm trying to remember what I've built in German. I haven't built nearly as much in German. I think stemming is no, because I remember I had a thing in Norwegian and the Swedish, and the stemming in Swedish was really weird. And someone was saying Finnish is something similar, but I don't know who's ever built NLP in Finnish because it's just it's a really hard.
It's on its own branch of the language tree and everything. It's
it's totally
it's not Germanic or it's totally its own thing.
So Duncan Healy had a question here about wrong characters.
I think he was answering just about how do you spell Chinese wrong.
Sorry. It's word. As far as I know, it's words that if you spoke them out would sound the same. People can see. So when someone sees a misspelling, they go, "What are they saying there? I don't understand it." And then they say it to themselves, and they go, "Oh, that's what they say." So, okay. Any specific issues? So Chinese is an amazing language. It's much clearer grammar and everything than English. English is basically, a bunch of Norwegians are pretending they're fancy, landed in Normandy, and the bunch of Vikings, and then sort of pretended they were French for a while. So it's like German with a French grammar with loads of other stuff stuck on it. It's just a complete pig language. But anyway, so another issue, there's lots of issues with Chinese, and a lot of it's fascinating. But for example, one of the things is pinyin, the way they combine the sounds to make words, was invented by this guy who died, I think it was maybe the year before last now at this stage. And imagine that in your LinkedIn. I invented text. It would just be so weird if you know what I mean. That the fact that the people who first got this sort of stuff into a digital format are still around is kind of amazing. Stemming and lemmatization is something important in NLP, and this is coming to those language issues where certain languages, or if you think of it in English, it's easy to think in English. If you think of some words like consider, consideration, considers, considering, they all kind of mean the same thing. And if you stem them all back to consider, you can say, right, that kind of gives us more information in the sense of we have this more common signal. whenever someone is considered, we kind of know what they mean. You lose information because you lose information about time. In general, an awful lot of NLP, the big two ones that tends to make bad mistakes on is negation. Even in Google, at least last time I tried, you can't go to Google, tell me about Jaguar, not the cat. It won't. It'll just immediately show you the cat. You have to go not the symbol, the logical symbol cat to tell it not the cat. So most NLP systems aren't very good at negation, and a lot of them aren't very good with time. Trying to figure out the difference between should I have considered going to college, or should I consider going to college, or should I be considering going to college? It'll just see them as all kind of the same thing. So stemming is something to check at it, run it through your test, see if you get a higher accuracy score at the end. But it's not guaranteed, and there tends to be trade-offs. You might get better in general, but worse at certain kinds of questions and stuff. So just something to consider. And again, there's good libraries for stemming. I'll go into some of the details about the libraries later. There is two forms of Chinese. This was something Mick mentioned. There's transliteration. There's the traditional Chinese. It's still used in Taiwan and a few other places, but it's just a direct mapping to pinyin. So it's not something you need to be worried about. It's just a library that essentially does a regex and maps over. It's not AI. It's just this means this. There's the transliteration, and it's fine. And obviously, in any language, it just keeps going forever, but particularly Chinese, because it's just so rich and has been around for thousands of years. And it's the NLP in it is even richer than the normal NLP, if you know what I mean. Okay, so simple pipeline. Separate the text into words using LTP. You want to turn those string you now seen into a vector. What worked well for us was only count the words you've seen 3 times, because if you count every word, it kind of overfitted. I think we ended up keeping actually 2,000 words. We had bigrams, as in 2 words at a time, was what we were looking at. SVM classifiers are really good for this sort of stuff. You know, if you want to turn out an engine in a few days, SVM is really fast. I've mentioned some stuff here where I keep saying, add this, see if it works, and then see if it improves your accuracy, go back. It's quite hard to do those sort of steps with deep learning, because if it's taking you an hour or two to train up a test a model, you just don't have that quick pipeline. Whereas an SVM, you can train it up and check it in 5-10 minutes, and you can check, does TF-IDF work, does stemming work, does this work, does that work, and you can very rapidly get to a thing that will work pretty well. Whereas even if deep learning will work, if it takes longer, if you have more time, you don't have that time a lot of time, in this case, because we wanted to get something simple to get it deployed. So minimum 3 occurrences in the training data. So yes, any word that had occurred less than 3 times in the training data, we didn't put into, these are words that we consider important, these are the words we put into the vector. The reason for that is a lot of, well, first of all, we had 10,000 training cases, which is a fair number. And any of the words that occurred rarer than that, a lot of the time they were proper nouns, things like city names or dates and things like this, where it just ends up overfitting if we were adding them. Again, this is given the amount of time we had to check to build something quickly. There is a hack we added in, which I think helped with that minimum 3 occurrence issue, which I'll describe now in a sec. So anyway, that there. So classification algorithms, SVM, they work really fast. They're quite simple to understand. And early versions of Watson used them. They never tell you this, but they did. Now they don't. But if you want to do something quick and dirty using just scikit-learn, they're there, they're fast, they're nice. You can do a sort of a grid search to find a good parameters for them. That one you have to go off and get a copy for yourself or something. But again, that's sort of at the time. It's not days.
How many different classes were you training on, Dave? Like, how many were you trying to classify?
So we ended up with close to 100. There's always a fight when you're building chatbots, that obviously the client wants as many as possible and you want as few as possible. 50 is really the number you should be having, because if you answer the most popular 50 questions, that's like 80% or more of the time. When someone picks up a phone, that's so you're better off, I think, answering the top 50 questions really well than trying to go to 200, not quite as well. But it's just a fight you always have with the client, and I understand why they want to have as much answer as possible. So yeah, that's fine. So this is a hack that maybe gets around some of the sort of incredulity about the things you've seen less than 3 times get rid of. What we did and what Watson doesn't do is, if you have like an entity, a proper noun, those are the things that are capitalized, like name of a city, ticket number, date, those sorts of things. Watson doesn't treat that as an entity. It just goes, what am I going to do with that? I'll just treat it as the word Beijing. Whereas what we did was, whenever we saw those things, a bit like a regex, we said, stick at the end of the sentence in the training data, there is a city mentioned here. There is a ticket number mentioned here. There is a company we want you to use. These sorts of proper nouns, these sort of big letter things. And that means at the end of your 1,000 array, we have, I think it's maybe 10, maybe 20 entities to say, and by the way, this happens in the sentence. Because it tells you a lot. If someone says, I want to book a ticket from Dublin to London, maybe Dublin hasn't been mentioned that often. Maybe it's not in the training data somewhere else. But if you know, oh wait, they're doing something that involves the names of cities, that is a fairly big clue. And that actually boosted the accuracy by a fair bit. So it's a hack that a lot of the big engines don't do, and I don't know why, where you say, you treat entities, something that you know about, as something important, and you tell the training data, by the way, this important thing has happened in your data. Adding that hack and a few other little hacks as well got us to within like 1% of Watson's score, which, considering they have vast numbers of PhDs, and this was done by 2 people, one of which was an NLP person and done quickly, is pretty decent. There are other things you can do then to start getting better and better. Parts of speech tagging is used a bit, never that successfully, and it adds a bit extra complexity to what you're doing. So I don't know if it's worth it, in the sense of, you're trying to do something quick and dirty right now. Adding technical debt in the sense of another path through your system, I'm not sure is worth doing. This particular hack here with the entities is so simple and it helps so much that I think it is. But again, try it and see if it works for you. There's other stuff around bits of the parse tree and adding the back end and stuff that, again, the papers say they help. They do a bit, but I don't know if they help them enough to be worth the extra hassle, if you know what I mean.
Just ask Dave 2 quick questions about that.
Sure.
One, when you're adding the entities at the end, do they basically become dimensions then in your bag of word vectors?
Yeah, so you've got your 1,000 is now 1,010 sort of thing,
or whatever you've added. Yeah, I love that. That's just a great little hack. And I'm stealing that outright.
It's weirdly enough, you can do it a lot of time in other sorts of data. So
yeah, that's exactly what I'm thinking. Like that's that's quite universal.
Frequently you've got like image data, and you just sneakily stick in the time of day, the country, whatever, this sort of stuff in it. That now, it has to be fair. It has to be stuff you are going to have. But sometimes you can get a 1 or 2% boost from just a pure hack that way of metadata that can be. You can go, well, I have my classifier, and then I'll feed into another classifier with this extra data. But sometimes it's kind of easier just to stick the original data into your first classifier in a sneaky, hacky way. But yeah.
And the second question was just, when you're saying you're getting like a boost of 1%, I presume that's points. Is it like from 79 to 80, let's say?
Yeah, actually, I think it was more than that. He was 2% with that hack. Yeah.
But what are you going from to in terms of, like, what's the relative increase in accuracy then, roughly speaking? Like,
so this is back of the envelope.
Oh yeah, sure.
Usually, first time you develop a chatbot, it's 65% accurate on a k-fold test. You don't want to test too often against blind set just because it leaks data that way, if you know what I mean. You use that to sort of clean up your data set, as in you find questions you got wrong with really high confidence. A lot of the time you've just misclassified them, because when you start off classifying, particularly with a chatbot, you don't know how to classify. If you're classifying, is this a cat or a dog, you know that. But if it's, is this about cancelling a ticket or rebooking a ticket, you make mistakes early on, and then you kind of find them when you do a k-fold test and fix them up. And then there's other stuff. Actually, there's another one of the talks I gave about how to improve your data in that sort of way. But you're talking, a chatbot usually in the contracts won't go live till you're 80% accurate, which sounds low, but that's of everything someone comes along and says to you. And frequently people kind of make mistakes the first time they ask you. They say things like, oh, can I cancel my card? And you come back with, what card do you want? Or, I'm not sure what you mean. They go, oh, can I cancel my credit card? And so 80% includes times people kind of didn't give you enough information. But you're talking roughly 80% is where you want a chatbot to be thinking about launching it.
80% doesn't sound that low to me. But I come from finance where, it's notoriously difficult to predict anything. So, 80% sounds quite good, to be honest.
As you get more data, you can be going fairly up from there. But like 80% until you get to there, I wouldn't think about launching it. Is kind of the usual rule of thumb, at least. And even then, you're launching soft and trying to find errors, and that even trying to find errors to fix things. But so this wasn't deep learning. This was something you can deploy quick in a few weeks. Actually, it was less than that. It was like 2 weeks. Put it into Docker, obviously enough, because it's just really handy. There's the Docker. You should be able to run a good look. Oh, we can't. We need to get this signed or that signed. These happen. You want to find out that was going to happen early. Spacy is really, really good. It's really easy to use. It does. There's lots of parts you can use of it in these sort of pipelines where they're having to just go everything into deep learning. So I recommend Spacy to everyone now because it's really good. Some things it is missing some languages still, so it's entirely possible someone comes along to you and says they want something for some language that isn't common, and it won't be in Spacy yet, and you'll have to use a technique like this that will just work without having a huge amount of training data and stuff. But yeah, Spacy's great. Particularly word embeddings and stuff that you can get in Spacy that can really help things, because even with 10,000 training sets, there'll be just ways someone will ask for check luggage suitcase you've not seen before. Like, I don't know what a lingerie handbag is, but apparently that's a very close word. I've never seen a question with it, but anyway. So basic proof of concept. Stick this in a Flask. It returns JSON really fast on a laptop. You can, stick that in Docker, get that deployed quickly, and then you have to worry about, right, can we make sure it's secure? Can we make a more accurate set? Can we make sure it's robust to enough people? All those things. But if you have one you've handed over and you say, right, get this running, it gives you breathing space to go work on those other really important deployment issues and even just practical issues. And if they can't deploy, you say, look, we gave it to you a month ago. How come you can't deploy? And it just makes you, makes your life easier because there's someone else to blame, I suppose. Rasa is an open source chatbot engine. You can stick your pipeline into it. So, for example, to copy this pipeline, the sort of scikit-learn pipeline I described there, is really simple. It handles Dialogflows, it handles entities. There's a fairly steep learning curve because it handles them in kind of a weird way. But in general, it's the best open source chatbot framework I've seen. There's a new engine they've just developed called Diet that actually does something similar to the semantic stuff, like the entities mixing in with the normal classification stuff. It just does it in an awful lot cleverer way. I haven't fully tested it. I don't know how much more accurate it's going to be, but it's a really clever paper. It's a really good idea, and there's actually good videos on YouTube about how it works. So Rasa Diet, if you're into NLP, it's worth looking through those videos. Anyway, so what happened was the boss came along and said, you have to replace Watson and the many billions IBM put into it with you and one guy who isn't a programmer in a few weeks. And using Python open source tools, you can do certainly the question answering part, as in if someone sends you in a string, you'll send back, it's this label. Now, all the other stuff around turning a label into an actual answer, going to a dialogue tree so you can come back with a question and back and forth, you kind of do need a framework for that, and Rasa has that. But at least the question answering part, you can do pretty quickly with some fairly standard bits of scikit-learn and not use Watson. So that's my talk for tonight. How am I doing for time? Yeah, ask questions here. I can see you again.
We've loads of time.
I'll stop sharing my screen. Maybe.
Yeah, I should have pinged Flavia.
I shall share my screen. Yeah, you're screen again. Great.
So I've just asked people as well if they want to put questions in. Hold on, Flavio. Oh yeah, okay. I'm sharing the screen. Great. Thanks for that, Dave. That was great. I like. For anyone who's ever gone to any of my talks knows how much I love doing a simple thing quickly just to get it done, and you can build all the fancier stuff later. That does seem to be quite a universal principle. As in, it doesn't everything you were saying tonight. I work in finance and insurance, and I've talking to a couple of other people, and they're just kind of a universal principles of just get something up and working, and it solves all those problems. And then go back.
One of the issues is it's very easy to disappear for 2 weeks looking at some weird thing, and sometimes you have to do that. But at least if something's working, first of all, you have a score, and am I going to move the score by much in these 2 weeks? And that gives you some discipline just by that.
The dirty secret we had was when last year we were doing stuff in insurance, and we were trying to kind of display some tools to kind of do risk assessment, and I just didn't have time to build a model, so I just took some basic summary statistics and built a random number generator around those, and those were my model outputs, and no one ever questioned me on the outputs.
And did you have a dashboard you produced from that? Or?
Yeah, we were building a dashboard and all the other bits around it, and this was the model, and but it looked truthy.
Yeah,
and it was close enough because I had summary stats, so you could kind of see the parts where everyone knew the risk increased and the line went up, but no one ever really asked about the numbers and said they look wrong, even though they were a random number generator.
And what did you use for the front end of the dashboard? Not to bring things at this part, but
not at all. No.
Yeah.
I do it in Shiny, so I'm an R guy, so I write everything. I do most of my work in R. So one of the things I love about Shiny is you can spin up a web app really, really quickly. And then my colleague Michael, he kind of made it look pretty because mine looked like, as we call it, mine was the Minecraft version where I was just using terrible styles and it just. But then we kind of we found a few themes and stuff that can make it much nicer. And but exactly like you said, it got it in front of people, and it exactly did the job. We have a couple of questions in here. Hold on, let me just go through them. I have a couple of mine, but we'll get to them at the end. So the pipeline classifies the question, how does the chatbot answer? Is there one pre-canned answer per category?
So
that's from, I'm not sure who asked that question.
Niall.
No. Yeah.
No. So the question comes in, how do I cancel a ticket? And the closest to that is, say, the label cancel, ticket _ cancel.
Right.
And the question, the reasonable one is, how would you change it from ticket cancel to a piece of text that humans can understand? Rasa can undo that. There's some fairly simple sort of middlemen that says if the microservice returns this label, there's another microservice that says, well, I turn that label into this piece of text. Now, is it one pre-canned answer? Usually, essentially, yes. There's two differences though. One is the answer can change based on the entity. So you can have something like, if London, the rules for how big your bag can be in London Airport is this big, and Dublin Airport you're allowed an extra 10 kilograms, or something like that, where based on some entity the answer will change. Just to what I'm talking about, a big bad smell in chatbots is if you're using entities everywhere, you're a programmer. Programmers just use entities for everything. If the entity city, or if the word golf is ever mentioned, they must mean golf bag they're trying to take on a plane, and just ends up like one of these basic programs of got-tos everywhere, and it's just terrible. So just beware of overusing entities. If you're probably a programmer and you're probably doing it wrong. Then, of course, the simple things like a lot of the time you want to give out two answers just for A/B testing.
Sure.
So, a clever system will allow you to output two answers and you can see which one works better yourself later on. A/B testing isn't nearly as developed in chatbots as it should be, but it's easy enough to do even by just sort of a hacky way.
Give it a bit of time. So yeah, Duncan Healy, one of our regulars, says, how was the performance for the proverbs 4 characters plus in Mandarin versus English proverbs?
So maybe Duncan can type more questions. So proverbs no, probably not proverbs. Where's the word?
How was the performance for the Duncan? I know he's on there. Duncan, if you could just clarify the question. Actually, you know what? We'll come back to it. I asked the question about spelling mistakes. Here's we'll get to you in a sec, Paul. How do we test such an engine? How can you say testing is completed? That's from Abhilash.
So in general, and this freaks out software developers, it's never completed. You're never 100% correct, and there's always new stuff to learn. And anyone who deals data science or ML kind of knows that. And particularly chatbots, you never complete it because you've trained it summer, and all of a sudden you get questions about the snow on the runway, and you've not thought of that. Or suddenly COVID comes along, and there's new questions. So it not quite the question asked, but the long-term answer is you never finished. Short-term answer is your testing eventually in a chatbot has to be with people. You sit with people and you say, imagine you were flying tomorrow. What questions do you have if we went to the airport? These sort of user tests, and they have to say, I had a good experience with that chatbot at the end of the test. Or when you're going through the logs, you have to ask yourself, did the user have a good experience? The testing fundamentally has to be, did this work for the user? Now, you have to have all the numbers and stuff before that. You have to say, actually, it's 80%, 81%, 82%, our confidence is going up. These sort of solid quantitative metrics. But the book stops with the qualitative metrics of, did this work for the actual person? You can't let either one blind you, but you kind of have to stop with, we checked with 5 people, they said they were happy that they would use this again. It's kind of the last check you do with a chatbot.
Gotcha.
Yeah.
Sorry, Duncan came back there. I think he's like tiger heads, snakes, tails in Mandarin is all often. I presume it means you've got one thing in one language and completely different, but they mean the same thing with completely different words, is it?
No, it's a reasonable question, because Proverbs tell people things, but they don't tell computers things, because all huff and no puff doesn't mean anything. So it's just huff as a 1, puff as a 1, but it doesn't mean it to a computer.
Yep.
So it's an issue, of course. A lot of the chatbots are fairly transactional.
Okay.
In the sense of someone is trying to cancel a ticket, they are trying to check their credit card, they're trying to do these sorts of things. So because of that, it's not loosey-goosey, normal, proper, natural language, and you don't get as many of those proverbs. You do get them in complaints, but complaints are a weird thing, because I could give a talk on complaints, but complaints are weird because, first of all people complain about 10 things at once. So the food was terrible, and the seat was too small, and you lost my bag. And if you put all the complaints together in one intent, every single intent gets sucked into there, because it has all the possible words you'd ever have. So you have to be careful with that. I don't know, in image processing, what's the version of that? Maybe you have a bucket called street signs we don't know what they mean or something, and everything is stuck in there. So it's just complaints. You will get proverbs in. Complaints are quite difficult, but also a lot of the time you don't really have to answer complaints, because no one wants to hear it. The robot hears you're unhappy and he cares about your feelings. A complaint kind of has to be handed off to a person in some way. I think you're unhappy. Send an email to here, or we'll pass you over to an agent or something. So proverbs tend not to happen much in normal transactional chatbots. They do happen in parts like complaints, but a lot of the time complaints have strong other words in them that mean the fact that you missed the proverb. Your customer service was all huff and no puff. I'm never using this airline again. The huff and puff, you'd like to use, but if someone's used it before in your training data, or if you add this in because you think they got it wrong, you'll now know that. But a lot of the time, the rest of the words are enough to help. You know what I mean?
Getcha. Yeah, I know we had an issue when we were doing that a few years ago for a pension company, like a life insurance, and it was pension, around tax time, when the tax deadlines for filings and stuff. And one of the problems with sentiment analysis was words like outstanding, which is usually a very positive sentiment, but it meant, no, this task is outstanding and it hasn't been done yet. So it was and trying to get that very context specific stuff was actually quite a tricky task to kind of get a handle on. We have one question in the chat here before I'm. How do you typically go about maintaining the accuracy of QA systems once they're deployed? For example, ensuring the accuracy doesn't drop off if people start to ask about a known topic slightly differently. That's a great question.
It's a great question. So essentially, you have to go through the logs each week, and there's two ways to do that. One of them is just randomly look at X number of conversations, and the other one is look for bad smells. So look for times the confidence was low in your return. Look for times the person ended up going to a red path. Look for times someone left in the middle of a chat flow, because if you start, some chat flows people are leaving because they decide they don't want to buy the ticket or whatever. But a lot of the time, if a chat flow people are leaving it, you kind of want to look there to see what's going wrong. So essentially, it's fairly manual with some heuristics about where to look to see that things have gone wrong. But a lot of the time, it's just you got to put in the errors to see what people are saying, where are we getting them wrong, and if they're wrong, add them back into the data set.
Getcha.
Yeah.
Let's see, do we have any more? I just added one at the end, which is, this ties into what you were saying about links, but what recommendations do you have for a beginner and intermediate NLP resources to get up to speed on the various techniques? Because it's quite a big topic. I don't necessarily mean, Python or R or Java or whatever, Node. Just in general, are there any good? I mean, maybe you share, if you're willing to share your code tomorrow, we can.
Of course, yeah.
I'll add them to the list. But if there's a couple that stand out, one thing, beginner ones, but the other thing I found is people tend to focus on the beginner resources, and you get to low them, and you kind of go, well, where do I go next? And what are do you have any good like intermediate books in, like, I know the basics, I know what stemming is, and I understand TF-IDF. Where do I go next in terms of resources? So if you have like beginner and intermediate, that'd be great as well. Mainly for me, this is a very selfish question.
So it's a good point. There's a lot of sort of medium articles and stuff on here's your first NLP pipeline, kind of what I discussed tonight, but just kind of my point was, even that fairly standard stuff, particularly if you add testing to it quite rapidly, you can pretty good get a system working well for a language. Now the next step of the weirder stuff, there's good books, but a lot of them are 20 years old when I read them, or 20 years ago when I read them. So I'm trying to think if they're still great.
They probably are, to be honest. I mean, they
probably are, but they must
change.
But this is even weird. This is the sort of the languagey stuff doesn't change. But for example, I've not found a good. I'm trying to find a good deep learning book for NLP. I'm reading sort of two at the moment, trying to get that sort of intuition. I have a fairly good intuition using scikit-learn. I can tie something together in a day or two about that will work.
Yeah.
But I don't have that for deep learning. Like, I have a sort of, here's a generic network you use. It's probably okay, but I have no idea if it's good or not in a way I would with scikit-learn.
Yeah.
So it's telling you it's an intuition developed and doing it loads isn't very helpful to you. So
no, I mean, sometimes it is. Sometimes it's just a matter of doing it, and that's building intuition. That goes back. It's the point I always make is like building intuition. That's why you start with the simple things, and that getting something out there that gives you kind of your context, and you can figure out where your gaps in your knowledge are. But that's great.
Sorry, that wasn't a good answer, but it was.
No, it's hey, look, it is, because it's if there isn't any. I mean, if anyone else out there knows them, please let us know. We'll I certainly
good book, but
Foundations of Statistical Natural Languages. Okay,
cool. That's a good book, but the sort of NLP for not quite idiots. There's, Manning have great books. Again, I'm going through them, but I couldn't swear by any of them being perfect. This is exactly what you need to know. A lot of them focus on sentiment, which, like you said, outstanding. Sometimes you need your own sentiment classifier, but it seems to be what everyone goes to, and it's like,
it's at this point. I mean, at this point, to me, it's kind of almost like a bozo flag if you're talking about sentiment analysis on social media. It's like, we've been trying that for 10 years, and we still haven't managed to do it effectively because, it's essentially pathological.
Like Americans can't understand. In fact, half the time you read Twitter, you can't understand whether being sarcastic or not. So this is a really good course at FastIA. I'll try that myself.
Great.
But thank you, Duncan.
Yeah, thank you, Duncan. Okay, well, that's about it. Thank you very much, Dave. We actually filled out the hour.
All right.
The joys of questions. Like I said, David was very helpful to get me on the bus one morning, and even though I hadn't woke up, I suddenly had a talk for Dublin Data Science. So that was a great day. So if any out there feel like making me a happy person, please volunteer for another talk. Like I said, it's very laid back and relaxed. We're happy to help. We have a couple of kind of people that we're kind of putting feelers out to, but we're always welcoming more. It can be on any topic whatsoever. We don't really care, as long as it's like vaguely interesting and something data-y and uses computers. Please give us a shout. Myself, Richie, or any of the regulars that you see, we're happy to accommodate you. But that's about it. I see Flavia's back up, so Flavia's going to wrap up. And thank you all for coming this month, and hopefully we'll see you at some point in August. Dave, thank you very much. I'm not thanking Dave. Thank you very much for that talk. That was, I think, one last comment. The one thing I find it quite incredible is the technology has advanced to the point now where even though none of you spoke Chinese, you were actually capable of producing something reasonably useful with just one Chinese speaker to make sure that you weren't doing anything completely stupid.
It's kind of the process. If you have the A to Z process, you can sort of apply it to the next thing, if you know what I mean.
Yeah.
And again, I by the way, I was training up some Chinese colleagues so they can do it next. And as soon as they knew as much as I knew, they'll now know more than me. You know.
Yeah, exactly.
But, the job is always to train up the next guy. It is, you know.
But I still think that to me is quite a testament for how powerful the technology has become. Like, and you're not even using your deep learning stuff. You're basically using scikit-learn.
Yeah, because the training cycle is so tight, you can just sort of did it work.
Yeah. Brilliant. Thank you very much, Flavia. I will hand back to you.
Hi guys, thank you, Dave. Thank you, Mick. I'm just gonna let you guys know that if you were interested in more talks, just keep an eye on the Dogpatch website, and it's always a pleasure. Mick, this is our 3rd virtual event, so always a pleasure.
Brilliant.
Looking for the next one.
Absolutely. And if you keep an eye on both Meetup and LinkedIn, Dave, if you hand me any of those links, I'll add a bunch of links on there for people who are interested in any of them. Great.
Thank you
very much.
Bye.
Have a good evening.
You too. Bye.